In this section, we will look at substring searching problems and algorithms that solve it. In this video, we will learn more about the problem through an example scenario. First, we will describe a scenario where the substring search would come in handy. We will then list a number of algorithms that solve the substring search problem. There was once a wise old monk that lived in a monastery and had many friends. One day, the old monk fell very sick. He was rushed to hospital, where the doctors unfortunately told him there was very little they could do. A few days later, surrounded by his friends on the hospital bed, he uttered his last few words. True communication depends upon our being straightforward with one another, but the best way to communicate may just be to, and with that he passed away. His other monk friends were very upset. They had lost a wise friend. They also wanted to finish his saying so they could remember him by it. One of the monks had a great idea. What if the monk had read the saying somewhere in their library and was just quoting it? They all agreed that they should try to find these words written down somewhere. So they all worked around the clock, day and night in shifts. Reading through every single book, papers and scriptures, they tried to locate this saying. But they soon realized it was an impossible task. Their library was just too vast. It would take them a number of years just to read through a fraction of their library. They decided they should get help from technology. So they started scanning and digitizing their documents. After a number of years, they managed to finish with all their library. Now all they needed was some clever software that would look through the huge amounts of data and find their friends' words. More precisely, they needed a program which accepted a string and a pattern. It then returned the first index position of the pattern inside the text. If the pattern is not found, the program returns -1. As an example, consider the following text and the following pattern. The algorithm would find the pattern in the text and then return the position where the pattern occurs in the text. So in this example, the above would return 72. This problem can be solved in many different manners. A naive implementation, which we shall see in the next clip, has the worst runtime performance, although it doesn't require any pre-processing or extra memory space. The Rabin-Karp algorithm uses hashing techniques and has a worse case performance as the naive algorithm, although on average it performs better. Similarly, the Boyer-Moore algorithm performs as bad as the naive one in the worst case. However, on average it's much faster. The algorithm works by skipping parts of the text that cannot contain the pattern. It is therefore suitable for problems where the pattern to search is long, as this makes the algorithm perform much faster. The Knut-Morris-Pratt algorithm has the best performance in the worst case. It only scans the input text until it finds the pattern without any backtracking. We will examine this algorithm in more detail in a later video. In this video, we have introduced the substring search problem by giving an example. We have then refined the problem definition. And finally, we gave an overview on different algorithms that solve the substring problem.